Swayam Prabha. Digital India. Educated India.
Welcome friends once again to the MOOC module of NPTEL on handling large scale unit level data with STATA. STATA is the software we are referring, and from the next week onwards we are supposed to have started with the use of STATA, and STATA is the software we will introduce in the next week. So, have patience on it, and you will certainly get the exposure of how to use STATA. Without understanding the background of STATA, it is not that good to immediately introduce STATA. So, therefore, on the third week onwards, as per our schedule, we have planned to take you a journey through STATA. Now, so as a continuation to my previous lecture on sample size determination, so therefore, this lecture is titled as sample size determination 2, and so therefore, I do not have a specific introduction slide, and I will start from the previous lecture. Now, the previous lecture content was on understanding sample size through two important parameters. One is precision rate or the margin error, and second one is confidence level. Confidence level is very important so far as a tabulated value is concerned. What do you mean by tabulated value? Tabulated value is the standard value of either Z value or T distribution value, okay, or F distribution value mentioned in a tabular form, and that has been already accepted by large researcher and presented in a systematic table. So, we usually, when an individual researcher do study on a particular context, we have to take those tabulated value as our benchmark, and so therefore, benchmark level should not be exceeded or undermined by any percentage. So, if we are actually deviating from the benchmark, there are some limits of deviation. So, therefore, the limits are given already, either it is at 99% or 90% or 95% or any percent in between. So, we already discussed this, and let me come back to the presentation on understanding sample size through the precision rate and confidence level. So, there are two approaches when the sample size is not known and when the sample size is known, when the population size is not known and the population size is not known. Now, what do you think? What is in reality true? In reality, population size is not known. In many cases, in a large number of survey, we do not know the population size. Except a few experimental design, we know this is our population, and we know what who are our stakeholders. So, then only some planning can be made, like in a panchayat we know how many population are there. If it is targeted at a village level only and you do an experiment on it, okay, maybe on nutrition level, your total population is known for sure within a village, and total number of persons who are suffering from that particular disease is also known if you are experimenting on a particular disease. But what is going to be your outcome is not known. So, outcome we are not emphasizing here, we are actually referring to your population number and your sample number. If population is that much, then how much sample you are supposed to take. If population is not known, still we can also discuss about sample size. But just sample size, no single researcher in the world can able to give you idea of sample size. I think there are some misleading statement given by some faculty or the researcher in different platforms, like they simply say the sample size should be 30%, sometimes they say it should be 10%, it should be 2%. Okay, there are different numbers they say, and there are some misleading statement like let me start with 30%. If it is 30%, still for a researcher covering 30% is not that easy. Okay. So, but for sure if n tends to more than 30, we generally refer not a T distribution, it is a Z distribution. Okay. So, if it is less than 30, we generally refer to that distribution as student T distribution. We will discuss some of those distribution later, but at this moment I am just referring to you for your other related knowledge related to distribution of distribution and determining size. So, sample size, there is no standard rule for sure, just by if somebody is telling you this is my population, tell me how much sample should I take. For a PhD researcher, for a PhD student, always it is asked by the faculty or the the board that how much sample you have taken and why you have taken. So, in order to say why, you have to explain all those parameter or statistics I am referring. So, we require precision rate, we require confidence level, we require variance of the population, we require population size. 4-5 informations are actually always required in order to derive the sample size. But there are some other techniques proposed by Yamane and by Cochrane approach. They suggested some alternative approaches given a limited information. So, Cochrane and Yamane largely is used by the researcher, we have that in our content. Okay. As I mentioned, we have already explained this, I am not spending more time on it. Let me just put a tick mark on it just by emphasizing the fact that this is our margin error. Okay. And margin error or as also called acceptable error. Acceptable error is Z times the deviation, square root of the deviation we open square root of sample size, and this is written as E is equal to Z times sigma square root of n if it is there. So, accordingly we can convert that equation and we will derive n. That I will discuss, I am not putting more time on it. Let me proceed to the understanding once again on the finite population. If it is a finite population, if the population size is known as a ratio to the confidence interval, we are supposed to multiply the proportion of non-inclusion out of the total population, who are not included divided by who are the total population minus 1. If you are including that, the rationale behind this I have already discussed in the last lecture, but more statistical derivation can be followed from statistics book. Here we are not referring those statistical derivation, where our purpose is to emphasize sample size in detail and what parameter or statistics we are supposed to include for sample size. And I can derive step by step for you. I know that this is not easily understood, let me try to derive for you. Okay. So, Z is equal to sigma times square root of n. Last class I started deriving, but because of shortage of time I could not able to emphasize. Now, this is n minus 1, so it is square root. So, I have taken squaring of all those things. We have you can follow by squaring this Z times Z square sigma square. So, this will be n. Now, multiplied by this is n minus capital N minus this and divided by n minus 1. All right. Now, we will do some further adjustment to it. Now, if I simply multiply, take this out, n is equal to this Z square sigma square divided by n divided by E square times n minus n divided by n minus 1, this is there. So, let me further follow by multiplying this. So, Z square sigma square. So, let me take n, multiply n here, n times Z square sigma square divided by E square times n minus 1 minus so n times small n times, that is capital N, this is now small n times z square sigma square. So, this is E square. So, now what I will do, I will take small n to the left hand side. Now, this will be n. So, I have taken, so it will be 1 plus z square sigma square upon E square, alright. So, this is equal to capital N z square sigma square E square times n minus 1. So, this is the equation we have derived so far. Now, what is left here? So, what is left here is this. So, n times this is E square plus z square sigma square equal to n z square sigma square, now E square n minus 1. So, more or less we have arrived into this position. Now, what is there for us? So, what is there anything missing? N equal to this. So, what I have mentioned here, I have taken E square that side. Now, now E square is taken to this level, to the left hand side, E square is here. So, n times, so it is 1 plus z square sigma square divided by E square. So, E square plus z square, okay. So, that is here clearly given. Now, so in our equation it will be now multiplied with E square, okay. So, what we will do here, so let me take n here, n is equal to capital N times capital N, then z square as per our equation, then sigma square is already given. Now, E square is also multiplied, whole divided by so n minus 1 E square is there, alright, times E square plus z square sigma square. So, these two are actually added. So, now what is extra added here? So, E square is actually added, okay. E square could have been taken, E square if I take out, then what is left is, if I take E square out of it, it will be of, okay, this will be then E square n minus 1 times E square, okay. So, now now what I will do, E square is taken out. So, the numerator remains constant. Now, this is basically if I take E square out, now this is n minus 1 times another E square is there, then plus z square sigma square, okay. Now, in the numerator n is there, z square is there, sigma square is there, so E square is there. Now, E square cancelled out. So, we have actually derived the equation as desired for sample size calculation. So, this is nothing but the equation as I just mentioned, as I just derived, okay. So, finally, our n is of small n is equal to z square times capital N is defined, we have already defined, and sigma square n minus 1 E square, and z square and sigma square. So, this is the final n. So, now this is the equation derived, and I have presented before you for a systematic derivation. Now, based on this we can apply for any calculation. Now, I have already discussed this. If the sample size is given and some researcher wanted to estimate the true weight of the cereal containers for the sample size of 5000 on the basis of following information. If the variance is there in the cereal container baskets is of 4 ounces, on the basis of past records. Some past records are taken, and it is very difficult to estimate the present record because you do not know the present population and their estimation. So, therefore, some past estimation could be considered as your basis. And if you allowed 0.8 or 8%, 0.8 ounces as your estimate to be within 0.8 ounces of the true average weight with 99% probability, that means 0.8 is your 8 by 10 is your margin error. If you allow that, that means 80% is your margin error or acceptable range. If that is the case, what you will do, acceptable range is 80%. With that, if you apply in the formula, you will get 41 is the sample size, that we have already discussed in the last lecture. Now, as I mentioned, how many indicators you want, how many indicators you want, population size, you want standard deviation or the variance of the population, you want acceptable range, then you want standard table and its value at 99% as given, or even any other level 2.58 as the standard table value, and so if you apply it, you will get the value as 41. But those 4 indicators, 1, 2, 3, 4 indicators may not be available in reality. So, with the limited information, how could able to derive it? Now, for example, if the population or those informations are not given, only probability of success and failure or success is only given. Firstly, you have to specify the precision and confidence level in this context. The confidence interval for population proportion, if it is denoted by p head, so the limit p head as if is the sample mean, p head, or the p is the population average probability of success, and p times q, as I already mentioned, if this is the distribution, usually these are referred in the context of Poisson distribution, where probability of success and failure is given. So, the mean of the Poisson distribution is actually p, whereas the variance is actually p times q. Okay. So, the standard deviation is actually p times q square root of n. Now, so if this is the context, then what is the confidence interval? Then this is the p plus minus the way we have already written z times z, if you convert that distribution into z values, okay, z values. How to convert? So, conversion through z value is x minus mu by standard deviation. If you do that, so z values can be converted, and times if we p plus minus z times p q, that is variance divided by n, basically we are multiplying with the standard deviation of that distribution, that defines the confidence interval of this kind of distribution. So, our acceptable error or the margin error is going to be E is equal to z times, from here as I have already said defined, z times square root of p q upon n. So, now here it is given sample proportion as p, q is non in proportions, and n is the sample size. Now, so then on the basis of the same formula we can define n, the sample size is equal to z square times p into q divided by e square. So, but in case of finite population, if population is not known, and that is the equation. If population is known, then you have to multiply with n minus 1, rest are same, n divided by n minus 1 is there in the previous equation, we already derived that, n divided by, finally n divided by n minus 1 content must have been there. So, here also n divided by n minus 1 is there. And if you apply, we will get the result. So, we are not mentioning much on it. Now, on the basis of this calculation where proportions are proportions are there. So, Cochrane actually formula is based on this particular format. So, one such example is given to estimate the sample size given a proportion. okay, proportion information is given. Suppose a professor in a department is trying to actually get the proportion of students, a professor in a department actually trying to get a proportion of students who actually support gay marriage, and she simply asks that how large a sample size do I need in order to understand gay marriage. Okay. So, the required steps here to understand this question, that how large the sample should I get to understand proportion of gay marriage. So, the margin error suppose is given as 2.5%, that is in a two-tailed test. Had it been a single test tail, it could have been 5%. Okay. In a two-tailed test, it is defined divided. If it is two-tailed, then that error is actually divided into two parts, divided by half. So, 2.5 and 2.5. So, and the confidence interval is 95% or any other different number. Some guesstimates are also there. Guesstimates, like usually in the society there are 30% who actually support gay marriage, not more than that. It cannot be 50% and 50%. Very less percent of people who generally support gay marriage. If these information are there and based on the margin error, 1.96, that is if you have a confidence interval of 95%, the Z value is of 1.96. I have already mentioned in the last lecture. The Z value based on the confidence interval, we can able to find out the Z value as 1.96. Now, that is actually 9.5 times the standard error. So, what is the standard error? So, standard error is actually defined is here, that is through the Cochrane formula, which was actually proposed in 1977, where they discuss margin error as mentioned by Cochrane is 1.96, that is Z times P into Q divided by n square root of n, that is standard deviation if proportions informations are there. So, P Q divided by n and square root is nothing but the standard deviation times the standard value, that is 1.96. So, based on this formula we can calculate the sample size. Now, sample size can be calculated. What information are there? Only probability, that is 30% if you are suggesting here, 30% people based on the guesstimates are known. There are many contexts like related to gender issues, related to health issues, related to gender violence, related to epidemic. There are various contexts by which we can have lots of guesstimates for understanding the sample proportion. So, basically two information are required, one is sample proportion and we require confidence level. So, if two information there, we can estimate the another one is margin error. If three information are there, we can derive the sample size. Now, so based on that formula we have already derived. So, Z score for different level are there 1.645. If you check the table, Z table, these information are there. You just simply go to the Z table, open that Z table. Usually these are given in the back of the statistics books. Okay, go to the Z table, check the 90% on the row and column. You check some percentage are given, 90%, 92%, 93%, 99%, all percentage are given, and the column you will find out at what level you require. Okay. How many sample size you have? Actually, sample size is also given. Now, based on that, the Z table can be suggesting you the standard Z value. So, the Z value at different level is once is calculated like this 1.96, 1.645, 2.54 if it is there. Now, our N0, that is sample size is equal to as per the formula. This is ME, marginal error we have already defined as 2.5%, that is basically 0.025. So, 1.96 is our standard value, Z value, and this is probability of portions or the proportion of people who supports gay marriage, that is 30%. So, 1 minus P is 0.7. On the basis of that we can calculate the sample size. So, now for here sample size you do require is 1291. So, around you can stick to 1300. Okay. If you stick to 1300, that will be guaranteeing a 90% confidence level, that it is confidently a researcher can claim that my result is going to be robust, because my sample size has captured, sample size has captured the true population with 90% confidence. Okay. Now, based on that, if you change your confidence level to 95%. So, 95% confidence level, we start with what 1.96, that is 95%, sorry. We start with 95% in our previous examples, where our n boils down to be 2091. Now, when you wanted to reduce your confidence level to 90%, your Z value is 1.64. On the basis of that, your n is determined as 909. So, what do you mean by that? When you reduce your confidence level, your sample size actually reduced. Okay. So, when you want to have higher confidence level, you have to increase your sample size. Okay. So, this is clearly proved through the Cochrane formula. Now, when you have no idea of sample proportion, but in that case you have guesstimated or have certain proportional information, but in number of cases their population and its proportion is not known. In that case you have to guess 50%, 50% of success and 50% of failure. So, 0.5 is considered to be P. You have to assume that if you do not know about probability of one as against another one or success as against failure. Okay. So, like how many support the government, there are many contexts. So, if you have a distribution which is actually Poisson type, success versus failure, favor versus against, if these type of context and data is there, you have to guess. If guess is correct, then your estimation could be correct. Now, if it is 50%, then n is actually going to be much higher, that is 1537. All right. Now, let us come to Cochrane formula for calculating sample size when the population is finite. In that case, we never refer population, the population size is nowhere referred. When the population size is actually referred, the formula boils down to here, the sample size divided by, that is n small n divided by 1 plus small n minus 1 divided by capital N. Okay. So, let us cite one example here. The example is a tax assessor wants to assess the average property tax bill for all home owners in one town, let it be Madison is given here. A survey 10 years ago got a sample mean and standard deviation of $1400 and 1000 respectively, okay, for their mean and standard deviation. Mean is 1400 and the standard deviation is 1000. The taxpayer is actually trying to assess the mean property tax by the for the all home dwellers. So, how many tax records should be sampled for a 95% confidence interval with a margin error of 100. Okay. Now, look at margin error could be anything. If you set a margin error of certain level, okay, margin error of $100, that is $100 you are saying, if it is mean, if $1200 and your margin error is $100, may be acceptable. Okay. If margin error is more than that, generally is not acceptable. So, what you apply, start with the formula, the margin error is equal to, here since the sample size we are restricting to a particular distribution, we are referring to T distribution, okay, and it is a small sample size, and in that case T is written. So, in the place of Z and T is deliberately written, and S is your standard deviation of the sample, okay, and why S is referred, because we are referring to a T distribution. Sigma could have been written if it is a Z distribution. So, S by square root of n is actually called standard deviation if it is a T distribution. So, n is equal to S times T divided by margin error its whole square. Okay. So, all the information is given, we have a S is given, S is here as 1000, that is standard deviation is given 1000, and T is actually 1.96 8, that is 95% confidence. I have already given you those values 1.96, and margin error is actually 100. So, 100, and we get when n is equal to based on this formula we get n is equal to 384. Okay. So, Cochrane formula could able to actually give us a clear result of 384 if very less information are given. Now, you have got examples for it. We have certain other formula when very limited information is given, called Yamane formula proposed in 1967, where the population information if it is there and margin error is there, only population and margin error two information is there, you can able to find out the sample size. Okay. Now, here the sample size is equal to capital N times 1 plus n e square. So, what is that? Small n is the sample size, capital N is the population one, and e is the sample error, usually considered to be 5%. Now, here based on this Yamane formula, we could get the information like from the table. Look at this, population size is given on the second column, the first column schools information are there, first school, second school, population size is there. Sample size for 95% level of confidence with 5% error, and that or 7% error or 10%, there are different indicators are given. If you simply enter the population that is 450, you can enter here, plus 1 plus 450 times the error, that is 0.05. Okay. So, 5%, if we multiply that, this boils down to a sample size. So, accordingly if you change the margin error, you will get other sample size, and this is considered to be the easiest formula so far as sample size is concerned. Now, another example is given, two districts of Odisha, we can also cite by referring an example from a data, but now I am deliberately skipping based on my own calculation. I have collected like Balasore and Mayurbhanj selected for a personal interview. If two districts in Odisha are selected for personal interview, the rationale of the same is presented in appendix. We will provide some of those information in our appendix as a content for your preparation. Okay. At this moment we are not including. Okay. So, total number of urban households in Balasore district as per the census data, I am not including everything because number of slides is exceeding. So, 47,360, whereas in Mayurbhanj it is 35,900. This information is clearly given so far as population is concerned. The total number of samples selected from urban areas as per the Yamane formula are 398.0875, which is roughly around 400 household, and similarly for another 397 or 400 are selected from rural areas, since the total number of rural household in these two districts is 107275. So, if I apply this number, I can get the proper calculation through Yamane formula, and this table will provide it certainly for your reference in your final preparation. So, what is the takeaways so far as different calculation is concerned? Now, here we are also suggesting something called Bayesian statistic. Those who wanted to go for advanced analysis, there are some variance, stochastic variance information is required. Okay, estimated stochastic variance, stochastic information if it is there, EVSI is there, this approach is applied, but this approach is largely applied when we are interested to also estimate the cost related to the sample size determination. And here the sample size EVSI, that is little complicated, so therefore we are not including it because it is not our purpose of emphasizing. I am just mentioning for your reference. So, EVSI minus cost of sample is generally referred so far as sample size is concerned, but this is very useful when you are very much concerned for cost estimation. So, what are the thumb rules so far as estimation is concerned, so far as sample size is concerned? The thumb rules are, so the first purpose of understanding the thumb rules is that how accurate your estimate is. So, the thumb rule as sampling error is actually inversely related to the size of the sample, as we already know the general thumb rules, but these are required. The size of the standard error is also important, that depends upon the size to a great extent, and it varies inversely with the size of the sample. And there are also in so far as theory is concerned, central limit theorem is important, which suggests that this assures that the sampling distribution of the mean approaches to the normal distribution as the sample size increases. So, therefore, when you are increasing a sample size, you are actually approaching toward the population mean. Okay. This fact holds especially true for sample size over 300. So, therefore, once not 300, 30, sorry, when it is sample size exceeds 30, we generally referred as not a T distribution, it is a Z distribution. Okay. So, or a normal distribution, but it is up to the researcher, but generally T distribution is required, because we generally narrow down by our approaches, narrow down all the data to a T format. Okay. So, what are the thumb rule here? Thumb rule is, the smaller your sample size, more likely outliers are there. So, unusual pieces of data and are there when outliers are actually more, and so basically the findings are very skewed. Okay. And so, sample size if it is more, Z test is applied, and Z test is more fitted. When it is small, T test is less than 30, T test is more fitted. Qualitative case, we require fewer samples. Okay. In case of quantitative estimation, we require large samples. So, usually a standard 10% rule is applied in many cases when your population is actually homogeneous. Okay. An assumption used for nearly every statistical test, that is T test, ANOVA, etc., is that the sample size should not be more than 10% of the population size, when the population size is known. When it is not known, then that is not also a standard rule. I think we have already discussed some of the thumb rules. We have already discussed some standard formula. We discussed so with certain examples, some calculations. I think those will be very useful for the learners. And friends, take a note of all those things. You might be in a position to prepare for your quizzes in every week for assignments, and these will be very useful. With this, let me stop here. We will see you in the next class. Thank you.